Let's start with our first section, which will be section 2.2, finding limits graphically and numerically. So let's say we want to look at the function x cubed minus 1 over x minus 1. Now from our review, we know that f of 1 is undefined. And if I was interested in the domain of this function, what would the domain be? It's everything but 1. So in interval notation, negative infinity to 1 and 1 to infinity. So I know my function's not defined at 1, but what I want to do is focus in on the following question. So I want to know what happens to my function near x equals 1. So I know my function isn't defined at 1, but what about nearby, close to 1? What is going on with my function? So we're going to discuss two ways to find what happens near 1. And the first way is numerically through the following table. So I'm going to go ahead and outline my table here. I want to know what happens near 1. Right, my function is undefined there, so I'm just going to put in a question mark in my table. But I could take values that are a little bit smaller than 1. So let's go with 0.75, 0.9, 0.99, and these are getting closer and closer to 1 here. And then I can also look at values that are a little bit bigger than 1. So 1.001, 1.01, 1.1, and 1.25. And then we're going to plug each one of these values for x here. In the top, we're going to plug it into our function f of x and see what we get back. So I'm just going to go ahead and fill in the table here with the values. 2.710. I rounded to 3 decimal places. 970, 2.997, 3.003, 3.030, and 3.813. So let's see what happens as I get closer to 1. So as I get closer to 1, as I increase up to 1, what does it look like my values in the bottom are getting closer to here? So it looks like I'm getting closer and closer to the number 3. So as my function, as I approach 1 from the left, my outputs approach the number 3. And now let's look on the other side. If I look at numbers a little bit bigger than 1 and I decrease down towards 1, what's happening to my y values? 3.8, 3.3, 3.0. It looks like they're getting closer to 3. So as I approach 1 from the right, f of x approaches 3. So it looks like near 1, my function is close to 3. Another way we could tell what happens near x equals 1 is to look at the graph of the function. So let's do that next. Let's look at the graph of f of x. So if you have your calculator, you can ask it to graph this function. And remember your domain, your function is not defined at x equals 1. So let me sketch out the graph here for you. 1. So here's my graph, and you do have a little hole there because your function is not defined at x equals 1. So if you look at this graph, you'll see it's a parabola with a hole at 1, 3. So if I look really close to 1, nearby x equals 1, I'll see that my function is really close to the value of 3. So in this case, we're going to write limit as x goes to 1 of my function, the limit is 3. So as I get closer and closer to x equals 1, my function, my output, my y values are closer and closer to 3.